Hello viewers. In this video, let's discuss about web services security for SOAP services in WSO2 Micro Integrator. WSO2 Micro Integrator is WSO2's integration software product that has been in existence for nearly about 18 or so years. It was first called WSO2 Enterprise Service Bus and then WSO2 Enterprise Integrator after it consolidated few other products into the same product line, and then a few years before actually it had removed a certain set of functionalities to make it more lightweight, and it rebranded its name as WSO2 Micro Integrator. But the underlying engine, all that is still the same that had been there since the time of WSO2 Enterprise Service Bus. So WSO2's underlying mediation engine is based on something called Synapse, which is dependent on another project called Axis 2. All of these are Apache projects, and why I'm mentioning all this is because all of this has been very crucial for the SOAP services. Because this is about web services security for SOAP services, I should also mention that SOAP in general is considered dead in the enterprise today. However, I still see it's lurking around in enterprise, in most scenarios for legacy reasons or whatever. It is still available. When you discuss with enterprise folks, we still see SOAP services being asked as a requirement because of whatever legacy services that may be having. So because of that fact, I still see having an solid understanding of web services security for SOAP services is very important. And WSO2 inherently had been, WSO2 Micro Integrator inherently had been a SOAP engine, and it had made its development over that for so many years. So it supports all the SOAP service functionalities and specification, and I should say it kind of have full support for web services security. So it supports about 16 different security scenarios for SOAP services. So this video is going to be a little longer because I'm going to explain about these 16 different scenarios. And so let's get started. The first thing that I want to discuss about is this username token scenario. So when it comes to web services security, SOAP services security, before the REST services security concepts like OAuth emerged, web service security specification was there, and it had been covering various different scenarios, and that's exactly what WSO2 Micro Integrator supports as part of its WS security implementation. So one way of achieving that security is username token. The person who's calling a SOAP service should send simply a username and a token, like a username and a password, along with the request, and that will have to be verified against the services user store. So that's on the server side. So how that happens is you cannot be sending all these things in plain text over the wire. For that matter, it's been mandated that such a authentication request should always happen over a secure connection, HTTPS. So in this scenario, message is secured at the transport level because HTTPS is at the transport level, and the username token is used for authentication. So simply the client will send the username token inside the message, wrapped inside the message, and it's then validated on the server side. Because it's sent over HTTPS, there is minimal security there, only the transport level security, and hopefully there hasn't been much, let's say, over the wire when it goes on, there hasn't been much of a tampering of some sort, and if you just be fine with that, you can rely on username token functionality. And at the server side, the message will be read and the username token extracted and then validated against the user stores uh, username token. And if that is valid, the service is successfully called and response is sent over the wire again. So all this information is available on the reference documentation of WSO2, so for which I have given the link as well. So I'm just have copied the diagrams that you can find in that link here in a presentation for ease of presenting. Let's move on to the second scenario, which is the non-repudiation scenario. The non-repudiation scenario basically says, even the client or the sender of a message cannot deny the fact that he or she sent the message. So that's basically non-repudiation. For this, the client should have an X509 certificate, basically a public key infrastructure certificate. That means usually these certificates are stored in a place called a key store. And let's say on the client side, as you can see, there will be servers or services public key. Private key will be within themselves, because private key is not supposed to be shared by any party, any entity with another person. It's something private to you. And the client's private key will be there with you, and the client's public certificate can be shared with the server, and the server's public certificate can be shared with the client. So in the non-repudiation scenario, how do we make sure that client cannot deny, or the sender cannot deny, that he or she sent or it didn't send the message? So one way to do that is like a signature in a normal document signature. When you sign a document, you cannot later deny that you didn't sign it, because you signed it, right? So that's how the non-repudiation works. So you can see in the description section, client should have a X509 certificate, and the messages, whatever the message that you send over the SOAP message, are signed using the private key of the sender. So the sender side, let's say the client is sending a message to the service, the client has a private key, and it will use that private key to sign the message, and you will get a signature part of it, and that will be embedded into the SOAP message, and it will be sent over the wire. And that kind of a scenario can be verified. Let's say this signature validation part can happen on the recipient side, because the recipient will now have the public key of the sender, and with that public key you can check the validity of that signature. And if that is valid, that means the sender has sent the message, and it's the same sender, like, because no one else would have signed that, because only the relevant public key can verify it only if the private key had signed it. So that's the scenario. That's non-repudiation. So that scenario is also supported in WSO2 Micro Integrator. Moving on to the next section, which is the integrity. Integrity is about, let's say in a real world scenario, let's say you have a document, and you need to make sure that document had not been tampered along the way. That means you sign a message, you sign some document. Let's say there is a financial document, and you have written 1 million check or whatever, and you sign it, and then you give it to someone else. Someone just adds another zero behind, which makes it 10 million, and that can be a real problem, right? So how do you make sure that it hasn't happened? So this is what the integrity part is for. So when it comes to the integrity, now again in this scenario, usually there can be situations where clients are unknown to a service beforehand. So in such a case, there wouldn't have been a scenario that client had sent the public key of its private key before the communication. So such a scenario, then it has to be dependent on what we call as, in cryptography world, symmetric key. A symmetric key is something that is not known to another party beforehand. right? So a symmetry can be used. So uh, the message is signed. Now you sign a message using the symmetric key. So you have that symmetric key. So that symmetric key needs to be accessed on the recipient side to make sure that signature is valid. But now you cannot send this particular symmetric key as a plain text or like in a visible manner over the wire. So how do we protect that? So that's where the sender's public certificate will be used to encrypt that symmetric key on the SOAP side. So the you encrypt with the recipient's public key. You encrypt using that key, which can only be decrypted using that recipient's private key. So this is the public key infrastructure methodology, right? So once you send that message back to the recipient uses its private key, which it knows the sender would have encrypted its symmetric key using its public key. So it will use its private key to decrypt that to get that symmetric key. So once you get hold of that symmetric key, what happens is the signature can be verified of the message. And then we know if the signature is valid, then we know the message has not been tampered along the way. And if it's not valid, because once you use that symmetric key to check the signature validation, if it returns false or something, then you know that the signature validation fails, right? You will have the signature in the message itself. Once you get hold of the message, and then you verify the signature of that, and if that doesn't match, then that means it has been tampered. So then by making sure that it is matching, we can ensure the integrity of the message. So these are all like cool concepts which had now been replaced using various different ways when it comes to the REST world. So we can talk about those things at in another time. For the time being, let's discuss and move on to the other scenario. Now the confidentiality. When you talk about the confidentiality, now in the integrity scenario, you didn't bother about that particular message or whatever document uh, is visible to someone or not. You didn't care about that. Only thing that you cared about was its integrity, whether it was modified along the way or not. Whether someone had a look at that or not is something that you didn't worry about in the integrity scenario. But if that is something that you are worrying about, then there comes this concept of confidentiality. You cannot allow another person to even look at that message. It's like you are sending a check, but that check needs to be out of anyone's sight. Then you're talking about confidentiality. So to do that, again, clients do not have an X509 because it can be an unknown client. Then when you're talking about an unknown client like that, you're talking about a symmetric key, not an asymmetric key where there is a public key, private key pair. A symmetric key is only a single key, right? So the client will have its symmetric key. Then again, when it comes to a symmetric key, always when you send it over the wire, it needs to be encrypted because you cannot send that, you cannot make it visible. So how do you encrypt that? You have to encrypt using the servicer's public key or the recipient's public key, which the recipient can decrypt using its private key. So that step is there. Now in the client store, in addition to make sure the confidentiality, the message needs to be encrypted. The message will be encrypted using the symmetric key. In the previous scenario, in the integrity scenario, we didn't encrypt it. We just did the signing part. We just added a signature. So in this case, it will be encrypted so that it will be, you know, jumbled, so that someone who is along the way looking at it wouldn't know that what was the original message because it's encrypted. And then once the encrypted message is there, you need to also make sure you use the service's public key or the recipient's public key to encrypt the symmetric key that was used to encrypt the original message, right? And then you bundle everything together and send it to the recipient. On the recipient side, the symmetric key will be decrypted using its private key, and then you will get hold of the symmetric key, and then the symmetric key will be used to decrypt the message to unfold that. So that's the confidentiality scenario. So now we looked at non-repudiation, integrity, and confidential. Initially we looked at username token scenario. So 4 scenarios covered. The next comes the sign and encrypt. So you can sign as well as and then encrypt. So in this case, this kind of scenario can be supported using both an asymmetric key pair or the symmetric key. So let's talk about the asymmetric key pair, where you know the client and the sender or the client and the service had a previous relationship and they have shared their relevant certificates beforehand. So now in this scenario, client will have the service's public certificate and the service will have the client's public certificate, and each party will have their own private keys as well. Now how to sign it and encrypt it? So the client should have the X509 certificate, of course, its own set its own private key and all that, and messages are encrypted using the recipient's public key. Now recipient's public key is with you on the sender side. Let's say from client to service side, the client will have the recipient's public key. You will first encrypt the message using the sender's or the recipient's public key, which can only be decrypted using its private key on the other hand, right? Yeah, so it will be encrypted, and then what? At the recipient end, the messages are decrypted using the recipient's private key, and the message signature are then validated. You have to also sign the message, right? Before you send it, you also have to sign the message, and the signature is validated using the sender's public key, because you sign it using the sender's private key and encrypt using the recipient's public key. So the decryption can happen on the other end using recipient's private key, so that then after you decrypt it, you can get hold of the message, and then you can make sure the signature is validated using the sender's public key, which is now there with the recipient. So this is the sign and encrypt scenario using X509 authentication. And then again the same scenario with anonymous clients. So anonymous clients means you don't know the client beforehand. Then in that case, clients do not have an X509 certificate because it doesn't identify itself to the service beforehand. So we can call it an anonymous client. And then in this scenario, a sign and encryption will have to happen using its symmetric key, right? And then the symmetric key will be encrypted using the recipient's public key, which will be there with the sender or the sender side. In this case, client to service side, that will be there with the client, the recipient's public certificate. So you will use it to encrypt the symmetric key, which can then be decrypted using its private key on the recipient side. Once you decrypt it, you can get hold of the symmetric key, and then you can use that symmetric key to again decrypt the original message and then also validate the signature. So that is sign and encrypt scenario when it comes to anonymous clients. Then encrypt only scenario with username token. Now this scenario, again, it's for anonymous clients. You do not, that means the client do not have an X509 certificate. The message is then encrypted. The original message is encrypted using, now this is an encrypt only scenario, not sign and encrypt. It's only encryption scenario. So you encrypt using the symmetric key, and then the symmetric key is also encrypted using the recipient's public certificate. And along with that SOAP message, just like the first scenario, you also send the username token, right? And on the recipient's end, once the message comes, it first needs to uh, use its private key to decrypt the symmetric key and get hold of the symmetric key. And then what? That symmetric key will be used to decrypt the message. And within that message, you extract the username token. And then you validate against the recipient's user store. In this case, services user store. So these scenarios encrypt only username token authentication. So we are getting a little complex, but a lot of security is in place, one inside the other and so forth. So that is all of these security scenarios were specified in the specification to give the best security. But as I mentioned, in the rest world, things have been tackled in different ways, and I hope to have more videos created to explain those scenarios as well in future. And then you can go even further, sign and encrypt and username token. Now, in this case, again, when it comes to anonymous client, you will have a symmetric key, and that symmetric key can be used to sign the message along with the username token, all that. The message will have it. You can sign the message and then use that signature part, all of that together, you encrypt the message. And then the key will be encrypted again using the recipient's services public certificate. Then on the recipient side, it will be decrypted using its private key. Then you get hold of the symmetric key. Then you decrypt the message, in which you will find the username token, signature, and the message. Then you verify the signature, make sure that it hasn't been tampered. And after verification, you just go ahead and do even another validation using the user store. So that's why the username token authentication also there. So it's getting more complex, more and more scenarios added, right? So that is also supported. So then comes, there are some other advanced scenarios like secure conversation can happen when it comes to a service and security token service. So what does it mean by this? STS is security token service. And so how does this work, for example? Now, in this case, it's sign only scenario. So messages will be signed, but before signing, what do you use the signature for? What will be you using to sign the message? So how that signature will be done is you will have your own X509 certificate. Now, previously, you used various different scenarios. You used recipients' public certificate to sign, or recipient's public certificate to encrypt, and sender's private key to sign the message. Such kind of scenarios we supported. But to have more control and make it more local to a particular session, let's say you have one particular session, you don't have to have that lasting relationship. That means when you have your own private key public key pair and the sender's private key public key pair is there, let's say for a transfer of data, you will not rely on that for the sole purpose of security of that session. So for that matter, you get a localized, that means a session specific key for that particular session only. But to get hold of that session specific key, now you see that secure context environment section at the top of it, you send what is called a request security token, RST. And to request that security token, clients will use its X509 certificate. The client and the sender both together, it will use its certificate to request a security token based on that previous relationship that they had, the exchanged public key private key pair, what they can do is there will be a security token response, RSTR. In the security token response, you will have a token basically, and that token will only be valid for this session. And you use that token basically to the keys derived from that security context is used to sign the message between the service and the client. And that particular token need not be exchanged, because at this session, the STS or the security token service send the token back, and you sign the message using that, and when you send it, that token need not go on the wire, because security token service already has that token or its related certificates and other entities. So when the message comes to the other end, you know this scenario is happening and the security token service is on the services side. It can use that security token service to make sure the signature is validated. So that is the signing scenario in this case. And then similar scenario, the encryption scenario, same like the previous case, you used the previously available X509 certificates to establish the security context and then obtain security token. You do a security token request security token, and security token response, you will get a token, and use that token to encrypt the message, and on the other end you can decrypt it using that token. So that's this scenario. And then comes on top of this, sign and encrypt. Again the same scenario, you establish that security context using your previously available certificates, PKI infrastructure, and then you get the token for the session, and with that token you do the sign and encrypt, and then on the recipient's end you decrypt it and make sure the signature is validated. So that is this scenario. Yeah, so now this case can be done for an anonymous client as well. That means even if you don't have that previous relationship between the client and the recipient, then the client or the sender has the recipient, sender has a symmetric key with them, and that symmetric key can be used to establish that security context, and then a token will be taken back, and that token will be used to sign the message between the client, and also you can use the recipient's public certificate to encrypt the symmetric key, just like the previous cases. Then on the recipient's end, recipient's private key will be used to decrypt the symmetric key, and so that is just to the decryption part of it. And no, in this scenario it's only signing, right? So you don't encrypt it, so you don't need to send the encrypted symmetric key also. It's just a symmetric key can be used to get the security token from the security token service, and then use that token to sign the message. So that scenario will be covered. And the encrypted scenario, you see, once the security token is obtained, and encrypt the message again using the service and the client. And in this case, encryption can happen. No, again you don't need that symmetric key to be sent over. The symmetric key will be used to take the token from the security token service, and that token will be used to encrypt the message, and on the recipient's end that token will be used to decrypt the message as well. Okay, so now in this case, on top of that, the symmetric key will be used to take a token, And also you encrypt the message along with the username and token. So on the recipient's end, the message will be decrypted using that token and then again validated. Your username token will be valid, an additional security on that side. Yeah. So now in this case, sign and encrypt again. The sign and encrypt scenario, it's like you just do both that, right, using that token. And along with that, you also have this username token. So basically using the same symmetric key to obtain the RST, security token, and that security token will be used to sign and encrypt the message which has the username token as well, and which on the recipient's end can be decrypted using that token, and then signature is validated and also username token verified. So it's the scenario that we have. So with that, we have covered like nearly 15 scenarios that's available in WSO2 Micro Integrator. On top of that, I mentioned that WSO2 also supports 16th scenario, which is using Kerberos security. For that, you need to have a key distribution center. The Kerberos is a completely a different protocol again, and WSO2 Micro Integrator can support it. Basically, client will get the security. It's also just like the security token service, but that token will be taken from a key distribution center, and how that connection is established and how that token is exchanged and finally taken over. And then on top of that, you do all these scenarios, signing part, encrypt only part, and sign and encrypt part using that token. And then on the recipient's end, recipient will again make sure go that take the token from the token service, which is the Kerberos key distribution center, take the token and then use that to decrypt the message, verify the signature, all that. So that scenario is also supported. So with that, we come to the conclusion of this particular video. So it's just to explain various different scenarios in WS security in the WSO Micro Integrator. However, there is nothing specific for Micro Integrator here because it's WSO security. So this can also be considered as a generic understanding of web services security implementation of any compatible implementation of WS security. Hope you enjoyed the video. So I'll have more videos created on this, and maybe we'll use one or two of these scenarios to we'll take one or two scenarios of this and demonstrate in WSO Micro Integrator in a later video. Until then, take care and goodbye.